In this video, we're going to find the sine and cosine of 60 degrees or pi over 3 if we're working in radians. Just as we did when we found the sine and cosine of 30 degrees, let's start by putting 60 degrees in standard position in a unit circle. All right, now by definition, the sine and cosine functions represent the coordinates of this point, I'll label P, specified by 60 degrees on the circumference of the unit circle. So by definition, the coordinates of this point are cosine of 60 degrees, comma, sine of 60 degrees. All right, so if we can find these two values, the cosine of 60 degrees and the sine of 60 degrees, if we can find the coordinates of the point, then we'll know the sine and cosine of 60 degrees. Yeah. All right, well, based on how we read points on the coordinate plane, since cosine 60 degrees is the x-coordinate of point P, cosine 60 degrees must be this length here along the x-axis. It takes us over horizontally to point P. Well, sine 60 degrees is the y-coordinate of point P. Sine 60 degrees must represent this vertical distance to take us up to point P. All right, and since the coordinate system is set up in this with these perpendicular axes, it means that these pink and red lines must be perpendicular to each other, or in other words, they must have a 90-degree angle. So I'll squeeze in a little uh, box there to represent that 90-degree angle. Okay, so now we have a right triangle, and if we're able to find the side lengths, the length of the red side and length of the pink side, then we'll know the cosine of 60 degrees and the sine of 60 degrees. So let's go ahead and focus on that triangle. We'll kind of ignore the rest of the circle and just simplify things and just look at the triangle. So I'll go ahead and paste a copy of that triangle over here, and we'll go ahead and relabel some of our pieces. We lost the 60-degree labeling there on the angle. All right. Something that might be helpful would be to figure out what this angle is up here, this missing angle. And as we discussed in the video where we focused on 30 degrees, since the sum of the angles in the triangle is 180 degrees, what we could do is we could add 60 degrees plus 90 degrees, the two angles that we know are in the triangle, plus this unknown angle, and we know it's got to add up to 180 degrees. And with a simple calculation, we can recognize that this is 150 degrees. 150 plus 30 more gives us the desired 180. And so we realize that this missing angle must be 30 degrees. Well, look at that. We have the same 30, 60, 90 triangle that we looked at when we were focusing on 30 degrees, but now we're focusing on 60 degrees. But since it's the same triangle, we actually already know the lengths of the red and pink sticks. I've got a copy of that triangle we focused on, whoops, uh, previously in the previous video when we focused on 30 degrees. I'm going to grab it over here. And so recall this triangle that we created when we were trying to find the sine and cosine of 30 degrees. And remember that the short pink stick was, was 1/2 unit long, and the longer red stick was root 3 over 2 units long. And notice that the 30-degree angle is across from the 1/2 unit side. And so when we transition ourselves down into this new version of the same triangle, what we'll want to do is uh, label the side opposite the 30-degree angle that 1/2 unit value. And then also notice that the side opposite the 60-degree angle is root 3 over 2. And so we'll want to label the side opposite this 60-degree angle over here. The pink angle stick, notice, is across from 60 degrees. That must be root 3 over 2. Let me clean up that blue lose stuff. Oop, that's not what I want to get rid of. All right, I'll just leave it. Okay. Now coming up to our original triangle, notice that what this means is that this red little stick here is 1/2 unit long, and the pink stick is root 3 units long, root 3/2 units long, I'm sorry. And that then means that the coordinates of this point must be, well, cosine 60 is the x coordinate, is this horizontal value. We see that that must be 1/2. So cosine 60 is 1/2, comma, well, sine of 60 here is the vertical coordinate. We've discovered the vertical coordinate is root 3/2, so this value must be root 3/2. All right. And finally, we can draw our conclusion, which we've pretty much already established, but just to explicitly state the sine and cosine values of um, 60 degrees. The cosine of 60 degrees is, well, the cosine of 60 degrees is this x coordinate. We've discovered it's 1/2, so the cosine of 60 is 1/2. The sine of 60 is this y coordinate of our point. We've discovered that's root 3/2, so the sine of 60 degrees is root 3/2. And now we know the sine and cosine of 60 degrees.